find the time period for simple pendulum for small amplitudes. Over here, this is a string, massless string, idle string, the length is L, and over here there is a point mass, heavy point mass, which is hanging from the string itself. We are interested that suppose it is displaced from its mean position, so this will be oscillating like this. So if it is oscillating like this, we are interested in finding the time period. So we know that is our first step. If we stick to the steps, the step number 1 is displace the body by a distance, small distance, x or y. Second is find restoring force. Third is put restoring force into mass into accretion. So fourth is if accretion comes out of proportion to minus of displacement, this means SHM. And then we say t is equal to pi y by a, that is the time period for the SHM. So what we do is we slightly displace it by a small distance y, we displace it. So this mass, point mass, heavy point mass is over here. So what we see over here, that is mg is in this direction, right? We have displaced by distance y, let's write it over here. So this line, this is angle theta, very small theta. So this comes out to be, we can break this mg into two parts. One is along this length of the pendulum. So if this is theta, this and this, both of them, they are vertical lines, they are parallel lines, and this is transverse. So if this is theta, so this also can be theta. So mg has two components. One is mg cos theta, which is along this radius or along the length, and the second is tangent to this displacement, which is going to be obviously this mg cos theta. So this component is mg sin theta. So mg sin theta is a restoring force which is trying to bring back the body to its mean position. So this is the mean position. If we call it as A, this is B, and over the other extremities is going to be C. So this pendulum is oscillating between the extremities B and C like this. So mg sin theta is the restoring force which tries to bring back the body to its mean position. So we say, so first step is done, we have displaced the body by distance y. Second is restoring force. We say restoring force now is mg sin theta. This is equal to mass into accretion. So we can say mass into accretion is equal to mg sin theta. So A comes out to be g sin theta. So what we understand is the time period of this simple pendulum will not depend upon the value of mass of this point mass. Now this theta is very small because we have displaced this body by very small distance y. So as a result, once theta is very small, so we can use the sin theta, the expansion of sin theta by Maclaurin series is sin theta is equal to theta minus theta cube by 3 factorial plus theta raised to a 5 by 5 factorial minus theta raised to a 7 by 7 factorial and so on. So if theta is very small, this higher powers, theta cube, theta 5, theta 7, they will almost become equal to negligible. 0.1 may be small and its square is even smaller, 0.01. So we can very safely, in this case where theta is very small, we can neglect these higher powers of theta and we can say sin theta is approximately equal to theta only. We can put it over here. So A comes out to be g theta. Once A comes out to g theta, now we see that is this is length L, this y is part of arc of this circle. So we know in circle length of the arc, any arc, if this is S, this is theta and this is radius, that is connected by the formula S is equal to r theta. So over here if we take this distance as y and this is L, so we can over here we can write y is equal to L theta. Same way, that is as we have said S is equal to r theta. So instead of S now we have y, this is L, r is L, so theta, so S is equal to r theta or y is equal to L theta is one and same thing, right? So from here theta comes out to be y by L, we can replace over here. So A comes out to be g y by L, A comes out to be g by L into y. G is constant, L is constant, so it means acceleration is proportional to y. Also, when we displace this body from here to here, so displacement is in this direction, whereas restoring force in the opposite direction. Restoring force and restoring acceleration, they are going to be obviously in the same direction. So acceleration is in this direction, displacement is in this direction, so they are opposite directed. So it means acceleration proportional minus y. If this thing is done, so it means we say safely that this is SHM, because the necessary and sufficient condition for SHM is being met when we say A is proportional minus y. So then we can use the expression T is equal to 2 pi y by A, which is valid for the SHMs. So T, time period, comes out to be 2 pi. Over here if you say A is equal to G by L into Y, so this implies Y by A is equal to L by G. We put it over here, 2 pi y by A is equal to L by G, we put it over here. So time period comes out to be 2 pi under root L by G. One thing to note is 2 pi under root L by G is the time period of a simple pendulum for a very small displacement from the mean position. Had it been higher, if this theta is not small, then we cannot ignore these things, theta cube, theta 5, theta 7, these we cannot ignore these higher powers of theta. Then certainly we shall not be getting, that is acceleration proportional to minus y. And then if we cannot use acceleration proportional to minus y, then we cannot use this expression which is applicable only for the time period of the SHMs. If this is not SHM, we cannot use this expression to find the time period. In that case, the time period is going to be different. If this length of the pendulum is infinite, then it comes out to be T is equal to 2 pi under root R by G. You can take it as exercise. Try to find out, that is how we get T is equal to 2 pi under root R by G, where R is the radius of Earth and G is accident due to gravity on the surface of Earth. Also, when we study simple pendulum, we come across the word seconds pendulum. Seconds pendulum is a pendulum whose time period for one oscillation, that is time period is obviously for one oscillation, that is 2 seconds. So seconds pendulum has time period not 1 second but 2 seconds. If you put T is equal to 2 seconds, 2 is constant, pi is constant, G is constant, this L comes out to be almost equal to 1 meter, and to be more precise, this comes out to be 99.3 centimeter. So the seconds pendulum has a time period of 2 seconds and its length is 99.3 centimeter, that is you can say close to 1 meter.